everyone, welcome back to Quantitative Reasoning. Today we are in our final section of the course, and so we're going to be going through section 12.3, which is all about measures of dispersion. And we're going to be looking at two measures of dispersion today, and they are range and standard deviation. So let's go ahead and get to it. So y'all remember that in the last section we looked at measures of central tendency, and those were just different calculations that helped us find a number to represent the center of the data set. But another important characteristic of a data set is how spread out the numbers are. So measures of dispersion are used to describe the spread of data items in a data set. And two of the most common measures of dispersion are range and standard deviation. Now, I'm sure that you have calculated range before. Standard deviation you may not have. This formula is a little more complicated, and so we'll look at that in detail in just a few minutes. But first, let's look at the range. So the range is just the difference between the highest and the lowest data values in a data set. So it indicates the total spread of the data. And since it's just the difference between two values, it's very easy to calculate. We really don't even need a formula if we understand what range is. Range is the highest data value minus the lowest data value. And that is its biggest advantage. The reason we even talk about it at all is that it is so easy to calculate. And it does give us some small idea of the spread of the data. However, that also leads to its biggest disadvantage. Because it only uses the highest and lowest values in the data set, it does not give us an idea of how the data are spread between those two values. So just so you can see what I'm talking about, let's look at these three data sets. Now, they each have a range of 20. 22 minus 2 is 20. So all three of these have the same range. So look at this first data set. Can you see how these values are pretty well evenly spread from the smallest to the largest? They're not grouped anywhere in the middle. They're not all congregating around the center or anything. They're kind of spread out. But if you look at this second data set, except for the smallest and the largest values, all the rest of them are exactly the same. So they're very tightly grouped together. And then if you look at the last data set, the range is still 20, and halfway in between 2 and 22, you would find 12, but none of the values are near 12. They're all either grouped down toward the lowest number in the set or up toward the highest number in the set. So I just wanted you to see one of the big limitations that range has and why, even though it's very easy to calculate, we don't count on it for a lot. So let's look at example 1 together. Suppose the numbers below represent the years of teaching experience that the teachers in a mathematics department have. Find the range for this data set. So we see our list of data values here, and if we want the range, we just need to pick out the smallest and the largest. So the smallest number in the list is 5, and the smallest value is also called the minimum value. And then the largest value in this data set is 26, and another word for largest value is maximum value. So the range would just be the 26 minus the 5, and that gives us a range of 21 years. And now let's look at part B. The figure shows the price per gallon for unleaded regular gasoline over 4 selected years. Find the price range for these 4 years. So we know that to find range we need to do largest value minus smallest value. It's easy to see the largest gas price on the graph. That would be the one with the tallest bar. And so the largest value in the data set is 2.79. And then the smallest value would be the one with the shortest bar, so the smallest value is 1.17. So the range for these 4 values is 2.79 minus 1.17, and that gives us a value of $1.62 for the range. Now let's look at our other measure of dispersion, and this one is called standard deviation. Standard deviation is found by determining how much each data item differs from the mean. And one advantage that the standard deviation has over the range is that the standard deviation is dependent on all of the data values. And then the symbol for the standard deviation of a sample is a lowercase s. Now, before we take a look at the formula for calculating standard deviation, it is a little bit of a complicated formula. So let's practice first calculating the deviation from the mean. Deviation just means difference. So the deviation from the mean is the difference between a data value and the mean of the data set. So here's example 2. And we have a data set that contains 5 values, and I've got them listed here in the table. Now all we're doing here is finding the deviation from the mean, and so the way to find deviation is to do each data value minus the mean. And so to do that, we'll need to calculate the mean over here. So we remember that the way to find the mean of a data set is to sum all the data values together and divide by the number of values. So let's add these 5 numbers together and we'll get a total of 775. Divide that by 5 and the mean of our data set here is 155. So what we're doing over here is each individual data value minus 155. So when you calculate for the first one, 146 minus 155, you get a deviation of -9. Then when you do for the second value, 153 minus 155, you get a deviation of -2. And so notice that values that are less than the mean will have a negative deviation. And then our third data value is 155. So of course 155 minus 155 is 0. And so this one has a deviation of 0. And then for 160, we'll do 160 minus 155 for a deviation of 5. And then 161 minus 155 gives us a deviation of 6. And so this is something that we'll have to do for each data value when we calculate the standard deviation, as you'll see in just a minute. So I wanted us to have a little practice just calculating the deviation part of the formula. Okay, now here is the whole big standard deviation formula, but I don't want you to freak out because we're going to go through each part carefully in detail, and you'll recognize right here in the formula x minus x bar, that's the deviations that we were calculating a while ago. So you can see how the deviations play a part in the formula. Now let's look at each part in detail. So I've copied our formula for us right here. So we know that in order to use this formula, the first thing we're going to need is the mean. So step 1 is to find the mean of the data items, and that would be x bar. The next thing to do after you have found x bar would be to calculate the deviation from the mean for each value in the data set. So step 2, find the deviation of each data item from the mean. And so that would be x minus x bar for each value. If your data set contains 4 values, you'll have 4 deviations. If your data set contained 10 values, you would have 10 deviations. You have to do this subtraction for each value in your data set. Then look what the formula says next. You take each deviation and you square it. So step 3 is square each deviation, and that would be x minus x bar because that's the deviation, and then you square it. And then remember what sigma means. Sigma means we sum all of these values. So you'll have a squared deviation for each value in your data set, and you sum all of those squared deviations. So that part of the formula is sigma x minus x bar squared. In other words, the sum of all the squared deviations. Okay, then step 5, and I've copied our formula for us again here so you can see what's happening. So at this point, we have the entire top of this fraction. The next thing to do is to take this value from step 4 and divide it by n minus 1. So step 5, divide the sum from step 4 by n minus 1, where n is the number of data items. So that would be the sum of the squared deviations divided by n minus 1. And this is where we are in the formula. And then the last thing to do is to take that answer and do the square root of it. So that whole answer from step 5, do the square root, and that is finally your standard deviation. Okay, now I want us to practice writing this down because I feel like if you write the formula a couple of times, it will increase your understanding of how it works. And it doesn't come naturally to anybody. You will have to think about it a little bit, but after you've used the formula a few times, you'll understand it better, and although it is a little work, it's really not hard to do. But I think the key is being able to read the formula so you don't have to memorize what to do next. You can just read it off of the formula, because we're not going to ask you to memorize this formula. It will be on your formula sheet. Okay, so the formula for the standard deviation of a sample would be S equals, remember S is the symbol for standard deviation of a sample. We would start with the deviation from the mean, so X minus X bar, and then for each deviation we square it, and then we'll have a whole set of squared deviations. Remember, one squared deviation for each member of your original data set, and you sum all of those squared deviations. And then you divide that sum by n minus 1, and when you've done that, you take the square root of that answer. Now, it's important that we realize that this standard deviation is for the standard deviation of a sample, because the formula for the standard deviation of a population is slightly different. If you take statistics, you will see that other formula in statistics, but in this course, we will only be calculating the standard deviation for samples, never populations. So let's practice using our new sample standard deviation formula, and I've got the formula copied for you here, and we're going to find the standard deviation for this sample of gas prices, and this is the same graph that we saw when we calculated the range in example 1. So, like I said, do not be overwhelmed by this formula, but learn how to read it, and it will tell you what to do in each step if you know how to read it. So the first thing you're going to have to do is X minus X bar, but in order to do that, you need to know X bar. Well, that's just the mean. So let's start by calculating the mean for these 4 data values. So you know how to calculate a mean. We'll just add these 4 numbers together and divide by 4. So I'm going to trust you to do that on your calculator. 2.08 plus 2.79 plus 1.52 plus 1.17. Get a total there, and then divide by 4. And you should get a mean of 1.89. Okay, now the next 2 things that we have to do are calculate a deviation for each data value and square the deviation for each data value. And the easiest way to do that is in a little table like this. So I've got us this little table, and what we're going to do is copy our 4 data values down here in the left column. So let's go ahead and fill in 1.17, 1.52, 2.79, and 2.08. And then in the next column, we're going to calculate the deviation from the mean, so X minus X bar for each of these values. And then in the next column, we're going to square that deviation, so X minus X bar squared. So you can see how the table helps us keep up with what we're doing. So let's just take one value at a time and calculate the deviation, and then while we've got that deviation on our calculator screen, we'll go ahead and square it. So here we go. 1.17 minus the mean of 1.89 would be negative 0.72. 1.17 minus 1.89 is negative 0.72. Now, hit the square button on your calculator and then equals, and you'll get 0.5184. Now, notice that because we're squaring here, every number in this right column will be positive, won't it? Because a negative times a negative is positive, but also positive times positive will be positive. So all of these squared values are positive. Okay, now we take the second data value, so 1.52 minus 1.89, and that's going to be negative 0.37. Now square that value, so square button equals, and you'll get 0.1369. And then for the third one, 2.79 minus 1.89 will give you 0.90. Square this value and you'll get 0.81. And then finally 2.08 minus 1.89 will give you 0.19. Square that value and you'll get 0.8361. So here is step 2 and step 3 finished. And now what do we do next? What does the formula say comes next? After we find all the squared deviations, we sum them. So we add all 4 of these squared deviations together. So you'll say 0.5184 plus 0.1369 plus 0.81 plus 0.8361, and you'll get a sum of 2.3014. Okay, now that we've got the sum of our squared deviations, the next thing that the formula says to do is divide that number by n minus 1. Now we had 4 values in our data set, so for us n is 4. So this is the part of the formula that we're working on. So we'll take our 2.3014 that we had from the previous step, and then we'll divide that by n minus 1. So I'm going to write 4 minus 1, but now if you just want to type divided by 3 into your calculator, that will be fine, because we know 4 minus 1 is 3. So when you do this, you're going to get a decimal value that you're going to need to round off. And we're just going to keep 1 extra decimal place than what we already have here with these 4. So we'll keep 1 extra one, and that will make 5 decimal places. So I'm going to put that is approximately 0.76713. Now I switched to this wavy equal mark just to remind us that this value has been rounded. It's no longer exact. And it's okay that it's been rounded, and it's okay if you don't use this wavy equal. I just didn't want to confuse anybody into thinking that we should get an exact number here. This is going to be a rounded value. Now, what does our formula say to do next? After we have done this division by n minus 1, the last thing to do is to take that previous answer and do the square root of it. So now we're taking all of this that we've already done from the formula, and we're doing the square root of all of that previous work. So that is going to be approximately the square root of 0.76713. And so you've already got this number on your calculator screen. So now let me switch over to my calculator so I can show you the easiest way to take the square root of a number that's already on your screen. Okay, so what we want to do here is take the square root of this number that we already have on our screen, and we don't want to have to type this back in. So first of all, let me show you the square root function. It's right here. You've been using the square button. The square root is the second function of that button. So now notice what happens when I hit second square button. It gives me a radical and it opens a pair of parentheses, but it does not assume that I want to take the square root of the last number that was on the screen. So what I have to do is use this answer function. Look down here at your negative key at the bottom, and you see that label that says ANS. That is your answer function. So the calculator remembers the last number that was on your screen, and to call that back up, we want to get this answer. So we're going to hit second, and then that button that has ANS over it. And so the calculator is going to do the square root of the last answer that it calculated, and there is our standard deviation. Now, I only ended up keeping 3 decimal places here because our original data had 2 decimal places, and it's kind of an unwritten rule in statistics that however many decimal places your data set has, when you do these calculations, you keep 1 extra decimal place. So that's what I've done here. But you, when you're doing your homework, you always read the instructions in my lab, and however many decimal places they tell you to keep, that's how many you keep. Okay, here we have another data set, and this is a small data set because you can imagine that trying to use this formula with a large data set would quickly become a headache. So every time we use the formula, we're always going to use it with a small data set. We're just practicing here. So we're asked to find the standard deviation of the numbers in this sample, and so we have a data set of 2, 4, 7, and 11. Let's go ahead and write down our sample standard deviation formula that we'll be using. it helps a lot if you can look at the formula while you're doing your work. Okay, we know that in order to find the deviations, we're going to have the mean. So the first thing we do is calculate the mean of these four numbers. If you add these four numbers and divide by 4, you'll find that the mean of this data set is 6. So you write x bar equals 6. Okay, now let's have that little table that we used on the last slide. So we'll have one column for our deviations and then another column where we square those deviations. And so we'll just take each data value one at a time. For the first one, calculating deviation, it's the data value minus the mean. So 2 minus 6 will be -4. And then when we square that deviation, we'll get 16. -4 times itself is 16. And then for the second data value, the data value 4 minus the mean of 6 gives us a deviation of -2, and then square the -2 and you get 4. For the third data value, 7 minus 6 is 1, so the deviation is 1, and then we square 1 and it's still 1. For the fourth data value, 11 minus 6 gives us a deviation of 5, and then we square the 5 and we get 25. Now look at the formula. The next thing that it asks us to do is sum all of the squared deviations. So we need to find the sum of all the numbers in this last column. So you'll do 16 plus 4 plus 1 plus 25, and you'll get a sum of 46. And then the next thing after we have our sum is to divide that number by n minus 1. Now again, for us, n is 4 because we have 4 numbers in our data set. And so we're going to take that sum and divide by n minus 1. So 46 divided by 4 minus 1, which is 3. And that gives us a decimal value that we will have to round off. So I've written approximately 15.333. And then for the final step, after we've done that division, we find the square root of that answer. And so finally, our sample standard deviation is going to be the square root of 15.333, and that's going to be approximately 3.9. Now, a couple of things I want you to notice here, and this is a good example to look at them because we have these nice whole numbers to work with. So first of all, notice that our deviations add up to 0. If you were to add the negative numbers, they would add up to -6, and the positive numbers would add up to +6. And so our deviation column adds up to 0. And it happens that way every single time. That's why the formula has us square those values so that they all turn positive, and then we have something that when we add them up we don't get 0. Another thing I wanted you to see while we're looking at this data set is that the standard deviation gives us an idea of the average difference between each data value and the mean. Now it is not exactly the average of those differences for lots of reasons that don't matter in this course. But look at this. Here's our data set that we were working with, and here's the mean. And now let's think about the difference between the mean and each of these data values, and we won't worry about whether it's positive or negative, so we're not even going to call it a deviation. But the difference between 6 and 2 is 4, and the difference between 6 and 4 is 2. So this data value is 4 steps away from the mean. This data value is 2 steps away from the mean. The difference between 7 and 6 is 1. So this data value is 1 step away from the mean. And this data value is 5 steps away from the mean. So the smallest distance between any data value and the mean is 1. And the largest distance between any data value and the mean is 5. And we calculated a sample standard deviation of about 3.9. So the sample standard deviation is always somewhere between the smallest deviation and the largest deviation. And so even though it's not an exact average, you can kind of think of it that way. And what that means is data sets that have a smaller standard deviation, it means that they have values that are grouped more closely around the mean. And data sets that have a larger standard deviation, it means that they have values that are on average farther from the mean. Now let me show you how to find the standard deviation on your calculator. And so we're going to find the standard deviation of this data set, and you can tell that using the formula on a data set even of this size would be just a nightmare because our table would get huge. It would take forever to do it. Like I said before, it wouldn't be hard, but it would be time consuming, and we don't have time. So we are going to depend on the calculator to find standard deviations for us, and so let's take a look at that now. Okay, so of course we're going to be using the statistical functions on our calculator again. Here's our data set that we're working with. Let's go ahead and get into stat mode, so second stat, and then of course this is one variable stats, so you'll hit equal. And now we're ready to enter data, so let's hit the data button. And I'm glad that this data is in order because it makes it possible for us to use the frequency function so we don't have to enter each individual value. So our first value is 17, and down arrow, and that occurs one time, so down arrow. Second value is 20, down arrow, and that only occurs one time. So make sure that you down arrow past the frequency if you're not going to change it. The next value is a 21, and it occurs twice. So I'll enter my 21, down arrow, and then I'll change the frequency to 2. Then the next value is 23, down arrow twice. The next value is 25, down arrow twice, and then 28, down arrow twice. And then the next value is 30, and that occurs 3 times. So 30, and change that frequency to 3. Now we're ready to do the calculation. So hit stat var, and notice it says n equals 10, so we can just make sure that our data set did have 10 numbers in it, and you can count those and see that there are 10. If we arrow over one time, of course we can see the mean if we need that. Arrow over one more time for SX, and then you can see that the sample standard deviation for this data set is going to round to 4.8. Now, since you can see it here on the screen, I will go ahead and point out to you that this next value is the population standard deviation. Don't go there because we will not be using that number for this course, but you might see online, if you look up standard deviation, you might see them use that symbol. That is not the same value that we are calculating here. That is population standard deviation, and we are working with sample standard deviation. So make sure that you use the S. And now in example 5, we're going to compute the standard deviation for the data shown in this histogram. So here I am back at the calculator, and I'm all ready to enter a new data set. And really, if you know how to read this histogram, you can get the data from the histogram, and that's really the point of this example. So notice that there are bars over the 8, the 9, and the 10. So those are our data values, and the height of the bar tells you how many times each data value occurs. So for the 8, that value occurs 3 times. So I'll change that frequency to 3. The 9 occurs only 1 time. You can see the bar is only 1 unit tall. So I'll leave that frequency at 1. And then the 10 occurs 3 times because that bar is 3 units tall. So change that frequency to 3. And now when we hit stat var and arrow over to the SX, to the standard deviation, we can see that the standard deviation is 1. And that really is not surprising because if you think about it, 9 is right in the center of this data set. And in fact, if we were to look at the mean is 9. That means that there are 3 data values that are 1 step below the mean, and there are 3 data values that are 1 step above the mean. Then there's 1 data value that actually is the same as the mean. And so except for that 1 value that is a 9, the rest of the values are exactly 1 step away from the mean. And so it just makes a ton of sense to me that the standard deviation should be 1. And then let's practice finding standard deviation with the data in this stem and leaf plot. Now we are going to use the calculator to find the standard deviation, but before we jump over there, notice that these leaves are out of order. And it will be much easier for us to enter the data in our calculator if we put the leaves in order, because then we can use the frequency function on the calculator. So let's rewrite our stem and leaf plot. We'll have the same stems, of course, but the leaves just need to be put in order. So on this first row, I notice that we have 1 7, but it looks like 1 2 3 8s and 2 9s. And on the second one, it looks like we have 2 zeros and then a 1 and a 2. So this is the stem and leaf plot that we will use to put our data in the calculator. Okay, back at the calculator one more time, we are going to use the data as we put it in order. And so I'll hit second stat to get into stat mode, then enter, and then I'm ready to enter data. And so our first value, now remember how this works, our stems are the tens place. So this first value is 17. There's 1 17. So, and then I'll hit the down arrow twice. There are 3 values that are 18. So I'll enter my 18 and then down arrow, and that value occurs 3 times, so change the frequency to 3. The next value is 19, and then down arrow, there are 2 of those. Down arrow again, the next value is 20. See, 2 0, and there are 2 of those. And then there's a 21, down arrow twice because there's only 1 of those, and then there's a 22, down arrow again. And now we're ready to find our sample standard deviation. So we hit stat var and arrow over to the SX, and our sample standard deviation would round to 1.5. And now notice that the mean of this data set is 19.2. So something just slightly larger than 19, and what we're finding out here with the sample standard deviation is that the average distance from the mean for these 10 values is approximately, not exactly, but approximately 1.5. Okay, now the purpose of calculating the mean and the standard deviation and the range is to help us understand the data set better. We always want to know where is the center of the data, how are the data spread out, and a few other things that you would cover in a statistics course. But right now, let's just think about center and spread. So let's look at mean, range, and standard deviation for these 2 data sets. And what we'll do is once we have those 3 values calculated for each data set, then we'll look for one way in which the samples are alike and one way in which they are different. Now I'm going to count on you to enter each of these data sets into your calculator and get these values. And so if you do that for this first sample, you'll get a mean of 20 and a standard deviation of 2.2. And then the range we have to do on our own, but it's just the largest value minus the smallest value. So the range for this set is 6. And then for the second sample, if you enter these values in your calculator, you'll get a mean of 20 and a standard deviation of 10.8, and this time a range of 30. Okay, so we're supposed to come up with one way in which the samples are alike and one way in which they are different. So clearly one way that these 2 data sets are alike is that they both have the same mean, but they clearly do not have the same spread. You can tell by looking at the range that the values in this first data set are much closer together because the difference between the largest and the smallest is only 6. But for this second data set, the difference between the largest and the smallest is 30. So sample B is much more spread out. And we will go ahead and write down that one way they are different is dispersion, and you can see it from both the range and the standard deviation. Now let's concentrate on the standard deviation just for a second. If you look at sample A, the mean just happens to be one of the data values, and there are 3 values below the mean and 3 values above the mean. The largest difference between the mean and any one data value is 3, and that goes for the 23 and the 17. And the smallest difference between the mean and the nearest 2 values is 1. So we would expect the sample standard deviation to be something between 1 and 3, and it is. It's 2.2. For the second sample, here again is the 20, and again there are 3 numbers below the mean and 3 numbers above the mean, but this time the difference between the mean and the value nearest to the mean is 5, and that goes for the 15 and the 25. They're both 5 steps away from the mean, and the largest difference between the mean and any one data value is 15, and you can see that with the 35 and also with the 5. 20 minus 5 is 15. So for this data set, we would expect the sample standard deviation to be something between 5, which is the difference to the nearest value, and 15, which is the difference to the farthest away value. And sure enough, it is. It is 10.8. So I'm really trying to help you understand what the function of the standard deviation does and what it tells us. It is approximately the average distance from the mean to each data value. So here is example 8. So it says 2 fifth grade classes have nearly identical mean scores on an aptitude test, but one class has a standard deviation 3 times that of the other. All other factors being equal, which class do you think is easier to teach and why? Okay, so the first thing we notice is that they said that the classes have nearly identical mean scores on the aptitude test. So it's not a matter of one group of students being really much smarter than the other, but they said one class has a standard deviation 3 times that of the other. Okay, let's kind of picture what this might look like. If we take a number line and put the mean score on it, the class that has a smaller standard deviation is going to have scores that are congregated more closely around the mean. But the class that has a bigger standard deviation has the same mean, but the scores are just more spread out. So you have some students in this class with a really high aptitude and then others that are farther below the mean. So let's write down that the group with the higher standard deviation has test scores that are more spread out. That's what it means for the standard deviation to be so much larger in this group than it was in the other group. And a higher standard deviation means a wider range of abilities. And now as a teacher, of course, it's easier to teach when all of your students are kind of in the same place. The teacher who has the group with a wider variation in abilities is going to have to do some things to keep the higher ability students from getting bored and other things to help the lower ability students catch up. On the other hand, the teacher of the group that has the smaller standard deviation probably can vary her pace. She can slow down or speed up if everybody is picking up on what she's saying. And so this teacher is not going to have to work quite as hard to keep everybody at the same place in the lesson, where the teacher of the higher standard deviation group really has her work cut out for her. So we'll say that the class with the lower standard deviation should be easier to teach because their abilities should be fairly similar to each other. And then finally in example 9, let's get a financial example. So it says shown below are the mean and standard deviation of the yearly returns on 2 investments over a period of 80 years. First, use the means to determine which investment provided the greater yearly return, and then use the standard deviations to determine which investment had the greater risk. Explain your answer. Okay, so we can see here that for the small company stocks, they had a mean yearly return of 17.5% and a standard deviation of 33.3%. And then the large company stocks had a mean yearly return of 12.4% and a standard deviation of 20.4%. So what these numbers mean is that on average, for every $100 that somebody invested in these small company stocks, they got back a profit of $17.5. So they got back their 100 plus a profit of 17.5. And then people who invested in the large company stocks, for every $100 they invested, on average, they got back their 100 plus a profit of $12.40. Now, it doesn't mean that everybody who invested in these stocks got back this return, but it's just an average. That's why it says mean yearly return. So since $17.5 is better than $12.40, we can go ahead and say that the greater yearly return goes to the small company stocks. Their investors got a greater profit on average than those who invested in the large company stocks. But the second part of the question says use the standard deviations to determine which investment had the greater risk. Okay, so this is where we have to remember that these numbers are averages, they are means. So not everybody who invested in a small company stock got back a profit of 17.5%. Some of these investors in the small company stocks undoubtedly got back a lot more than 17.5%, but some of these investors undoubtedly got back much less, and some of them probably even lost money. That's where the risk comes in. Now, in order to minimize your risk, you would want to put your money with the investment where all of the results are as close to the mean as possible. The more spread out from the mean the results are, the greater of a risk that you're taking on. So the greater risk you have that your investment will be on the losing side. So look at the standard deviations. The small company stocks have a standard deviation of 33.3%, while the large company stocks are much more closely grouped around the mean with a standard deviation of 20.4%. So what that tells us is the small company stocks have a larger probability of falling far away from the mean. Now they could fall far above the mean, but they also have a larger chance of falling far below the mean. So for the second part of the question, we're going to say that the greater risk also belongs to the small company stocks, and here's why. The larger standard deviation means more variability in the returns, which means a greater chance of earning less than the mean. So basically, the larger the standard deviation is, the greater the risk is of earning something that's far below this average number. Okay, you guys, congratulations. You have reached the end of our quantitative reasoning course. I hope it has been a good one for you. I know it's probably not always been fun. I know it's been a lot of hard work, but congratulations on reaching the end. I hope it's been helpful and that you've learned a few things that you can use to help you succeed in your later courses, in your career, and life in general. Thanks for taking this course with us, and good luck on your final exam. Bye now.